Assalamualaikum and hi. Today in this video, my lab partner and I will explain to you about experiment M1. The title is Resistivity Measurement of Semiconductor by 4-probe method. Firstly, we go to objective. The first objective is to measure the resistivity of semiconductor materials by using 4-point probe. The second objective is to determine the energy band gap of semiconductors. And here's the apparatus that we will use for this experiment. First, we have probes arrangements and the sample germanium and an oven for probe setup and thermometer. Next, we move to the procedure, and these are the procedure that we have been using during the experiment. And these are some of the pictures that have been taken during the experiment.
Thank you, Nick. I am Tang Ho Yin, and now I will be doing the presentation for the data and analysis. As we can see in the slide, this is the raw data of our experiment. Question 3 is the analysis for this experiment. In this question, we need to plot the ln rho versus 1/t graph. After we have plotted the graph, we need to calculate the energy band gap of the germanium semiconductor. The raw data only have the value of T, temperature, and V, voltage. To obtain the value of rho, which is resistivity, we need to use the equation of rho equals to 2 pi s multiplied by V over I, which is current. S is the interprobe spacing, which is 2 mm. By substituting all the value into the equation, we will get the value of rho. Then, we need to learn the value of rho. After that, we also need to reciprocal the value of t. Finally, we have obtained all the value of x and y to plot the graph. We need to put all the value of t, v, rho, ln rho, and 1/t into a table as shown in the slide. One table is for increasing temperature and another table is for decreasing temperature. Since we have learned the value of rho, it will be the linear graph. To plot the linear graph, we must use the least square method in order to find the equation of the straight line and the uncertainty of gradient and y-intercept. We need to do two tables for least square method. One is to get the value of m, gradient, and c, y-intercept. Another table is used to get the uncertainty of m and c. This slide shows the least square method for increasing temperature. The equation of the graph for increasing temperature is 3.0254 times 10 to the power of 3 x minus 11.7317. This slide shows the least square method to find the equation of graph and uncertainty of m and c for decreasing temperature. The equation of the graph for decreasing temperature is 3.0960 times 10 to the power of 3x minus 11.9729. This slide shows the graph of ln rho versus 1/t for increasing temperature. This slide shows the graph of ln rho versus 1/t for decreasing temperature. Last but not least, we need to find the energy band gap of the germanium semiconductor by using the equation of rho equals to rho naught exponent Eg energy band gap over 2kT. We will learn both sides to cancel the exponent and move the rho naught to the opposite side of the equation. By rearranging the equation into y equals to mx plus c form, we will get ln rho equals to Eg over 2k times 1/t plus non-row node. By comparing the equation with y equals to mx plus c, the value of gradient of the graph is equals to Eg over 2k. By doing some calculation, we will get the value of Eg. We also can find the uncertainty of Eg, delta Eg, by using the equation of delta Eg over Eg equals to delta M over M. The value of energy band gap for increasing and decreasing temperature are 0.5212 plus minus 0.0369 electron volt and 0.5333 plus minus 0.0308 electron volt respectively.
Thank you, Tang Hoyin. Now I will do for the question part, the first one. The first question is, what is the advantage of four-probe method over the other conventional methods? The advantage of using a four-probe method over other conventional method is that we manage to obtain a more accurate result on resistance. This is because the four-probe has a very little point contact and spreading resistance associated with the voltage probe. Hence, more fair resistivity can be obtained. To put it more simply, the resistance of the four-probe will not be added to the sample that we test because of two wires inject the current into sample, while two more wires measure the drop against the resistance. The second question is, can we use an ordinary millivoltmeter instead of electronic millivoltmeter or potentiometer to measure the inner probe voltage, and why? For this question, it will be no, because the impedance of an ordinary millivoltmeter is low, hence it requires a high value of current to operate it. This is the four-probe setup, only a very little current will pass through it, hence it's not suitable. And for the first question, why a semiconductor behaves as an insulator at 0 Kelvin? The answer is, at 0 Kelvin, electrons in the valence band has no sufficient energy to jump into the conductor band of the materials. Thus, it can only act as insulator. Theoretically, at 0 Kelvin, electrons has zero thermal energy and does not even vibrate. Hence, it is bonded and bind in the valence band and not going into the conduction band. Now we move to the discussion parts. Based on our data, we obtain that the voltage decrease when the temperature increase. This indicates that the resistance of the germanium sample decreases. The band gap energy of the sample decrease when temperature increase. Less energy is required by the electron from the valence band to jump into the conduction band. Thus, the voltage decrease. And despite it follow the characteristic of semiconductor that we have known. And then we make a graph of lone resistivity and 1 over T, and a curve of obtained. Based on the graph, it is linear at relatively high temperature, but show an exponential relation at low temperature. And extrinsic semiconductor behaves as intrinsic semiconductor at high temperature. Based on the result, we get a slightly different energy gap was obtained. This may be due to the inaccuracy of temperature measured by the thermometer. The thermometer was in contact with the surrounding air in the oven, but not the germanium sample only. The difference in the specific heat capacity will result in a slight difference for the result. This is due to the rate of cooling and heating differs during the two process, so the system return to the original state at a different path. The percentage error obtained is 6.9% for increasing temperature data and 7.0% for decreasing temperature data. To conclude this experiment, we get that 4-point probes has a better accuracy in determining the resistivity of a semiconductor, and the energy band gap calculated is 0.5212 plus minus 0.0369 electron volt and 0.5333 plus minus 0.0308 electron volt. And these are the reference that we use for this experiment. And that's all from me and my partner for this video. Thank you.